Welcome to qnawire.
Okay, in this problem, we are looking at molecules in the atmosphere of the Earth, and we were asked at what temperature would these molecules, on average, be able to escape the atmosphere. We're given the escape velocity in the atmosphere, which is about 10,000 meters per second, and we're given two different gases. In part A, we're looking at oxygen molecules. In part B, we're looking at helium molecules, and for each, we're asked to find the temperature at which the average particle would be able to escape the atmosphere. So to do this, we need one formula. We need to know that the average speed of a particle in a gas, in an ideal gas, is given by this expression, 8 over pi kt over m. This is from kinetic theory. This is the average velocity of particles in a gas at a certain temperature, given their mass. So the only difference in parts A and part B is that the mass of the molecule is going to change. So the first thing we can do is we can rearrange this for T. So our escape temperature is simply going to be, doing a bit of algebra, pi m average speed squared. And this average speed is going to have to be our escape speed, all over 8k, where of course k is the Boltzmann constant. So this is our expression for the escape temperature, just doing about one step of algebra. So the only thing we have to do is we need to note that for oxygen, the mass of one oxygen molecule is about 32 U, where U is the mass of a proton, 1.66, 10 to the negative 27 kilograms. Cool. And for helium, its mass is about 4 U. So with that done, we can simply plug in our results. Also making note that the Boltzmann constant is 1.38, 10 to the negative 23 joules per Kelvin. If we plugged in all these numbers for part A, we would have a temperature of 1.9 times 10 to the 5 Kelvin, so something quite hot. And for part B, for helium, we would have 2.37 times 10 to the 4 Kelvin. So both of these are pretty unrealistic. These are extremely high temperatures, way above room temperature, of course. So it seems relatively unlikely that we would see any of these particles escaping, for the most part, at least on average. Helium can escape at a much lower temperature, but it's still way above what we would expect. However, it's worth noting that during the formation of the Earth, when the Earth was much, much, much hotter and the atmosphere was much hotter, these helium atoms might have actually been able to escape in large numbers. So that's just one point to make there. But anyway, that's it. Getting an escape temperature.